All right, so we're in chapter section 6-5, operations with radical expressions. We're going to look to simplify radical expressions with the product property. And this corresponds to page 415 in your textbook. This is example 1, entitled the same, simplify expressions with the product property. And so we're first given what I have written here, which is the square root of 12 c to the 6th d cubed. And what we're going to want to do is break this down into some component parts. And I'm looking to pull out things that would be perfect squares. So I'm looking at each term in here. I got 3 terms. I got 12, I got c raised to the 6th power, and I got d cubed. So 12, I can pull out a perfect square of 12 because 4 times 3 is 12. So I can have the square root of 4. And just be patient, I'm going to put it together. Now, c raised to the 6th power. If I take that exponent 6 and divide it by 2, that goes evenly 3 times. So I've got c cubed. Well, I'm going to leave it as c to the 6th for right now. C to the 6th. And if I take that d cubed, well, the index square, 2, goes into 3 one time, but it's got 1 left over, so I can take this and make this d squared. So now I've got the square root of 4 c to the 6th d squared times, remember now, 4 times 3 is 12, so I got 3, and I pulled out all the c raised to the 6th, and now I've got d, square root of 3d. Now I can simplify this portion right here. So let's do that. And so then I'm going to have, well, the square root of 4 is 2. The square root of c raised to the 6th power is c cubed. And the square root of d squared is just d. And then that's going to be times the square root of 3d. Shazam. There we go. We've simplified it. This is going to take some practice. You got to know your timetables. You're looking to try to pull out perfect squares, maybe even perfect cubes. I think on the next slide we're going to be looking at that. So you got to be thinking. Really helps to know your multiplication tables. So let's move on ahead. Okay, well, let's look at another one. This time we're going to be dealing with the cube root. So let's start right here. We've got the cube root of 27 y to the 12th and z to the 7th. Cube root of all of that. So I'm going to look at this term by term, see if I can simplify this. Now 27. Is anything that could be multiplied together by 3 times and get to 27? Well, it could, because I could go 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And so I could either leave that as a 27 for right now, but if I wanted to, I could actually say that that is 3 cubed. Let's see. 3 cubed. Y to the 12th. Well, 12 divided by 3 is 4. That's going to go in there evenly, so I'm going to leave this y to the 12th right here. And z to the 7th power. So 7 divided by 3 go in there 6 times with 1 left over. So I could say z to the 6th. And then that's going to all be times just the cube root of z. All right, now we can simplify our expression here on the left. Well, 3 cubed, cube root of 3 cubed is 3. The cube root of y to the 12th is y to the 4th. The cube root of z to the 6th is z squared. And that's all then times the cube root of z. And there we go, shazam, we have done it. Now, if we go back in this in reverse, if I were to take z squared times z, well, that's z cubed. I mean, that's z to the, we're talking about the cube root here. If I were to cube, let me say it this way. If I were to cube z squared, that would be z to the 6th, and z to the 6th times z is z to the 7th, which is what we started with. So multiplying exponents, you add them. Dividing, you're subtracting. We're looking for things that will go in there evenly. Our numbers are actually our numbers that are probably the most difficult in this is trying to figure out, what is the cube root of 27? What number multiplied 3 times together, 3 times 3 times 3 in this case, would equal 27? Well, it is in fact 3. So anyway, there's a couple of examples of simplifying radical expressions with the product property.